Hello, good morning. So, in today's session, we are going to talk about the TLS. So, last time we have seen this TLS or SSL tunnel is required between the client and a server for a secure communication, whether it's from the client to server via F5 load balancer or the firewall. We need an SSL tunnel, right? We are doing SSL decryption, SSL encryption, SSL offloading, all those stuff. But what is an SSL or the TLS tunnel? And this is a very fundamental for the TLS. So SSL or TLS tunnel formation or handshake. I'm not going into the depth of this, but I will just try to have it, try to connect the dots. So first thing, SSL or TLS, three foundational concept. CIA, like an American agency. CIA, it's a confidentiality, integrity, authentication. So confidentiality is like the encrypting the data. It's encrypting the message. Suppose there are two friends, A and B. A is sending hello to B, and instead of the plain text or something which he will encrypt it, right? So the other person could not easily identify it. Only B can identify it. What is written over there? That's a confidentiality encryption. Integrity. Integrity is something nobody can temper the data. If someone temper the data, then the receiver would easily understand, okay, this data is tampered. Suppose we have A and B, the friends. A is sending encrypted data to B, but in middle there is a guy, rogue guy C, who got this encrypted data, who is not able to decrypt it or understand the data. But what he can do, he will open the envelope. Under that envelope, he will just move the encrypted data and replace with the another encrypted data, right? Then it will send to the receiver A, receiver B. So what is done? A and B friends, they want to talk to each other. A is sending a encrypted data to B, but in the man in the middle, it's a rogue guy C who just take the encrypted data. He just tampered the encrypted data with other information, or he replaced this encrypted data with his encrypted data and sent to the receiver B. So the receiver B should be aware of it. Okay, this data has been tampered, or what is the or the integrity of the data have been compromised or not. So that is the integrity. So integrity of data should not be compromised. So the next is the authentication, whether it's a pre-shared key or done by the PKI, public key infrastructure. Authentication is like should be opened by someone who is supposed to open it, right? So authenticate it. So that is an authentication. So confidentiality, integrity, and authentication. Who? Okay. So for the now we have a TLS 1.3. This is something which is a TLS 1.2. The TLS 1.3 is much more advanced version and much more secure. But before going to the TLS 1.2, 3, we will discuss on the TLS 1.3. So there, this is not because we are not in the development team. We don't want to get into the other details of it, right? But as a network architect or network engineer, we should be aware of it. What exactly is happening? So what are the list of the messages, or what are the steps of the message? First, we have a client hello. So the client who want to establish a session with the server, he will send his hello message. Okay, and we have a certain number of information in hello messages. What are those information? For first is a version, right? What kind of a version is TLS using? Then the client will generate some random number. Okay, then the session ID, the list of the cipher suits, the list of suits, it's a collection, right? That is what will be used for the encryption and authentication and integrity. That's a suit, right? It's a combination of the different parameters. That's what's called the suit, right? The same thing which the server hello will do. Okay, so the once it receives the client hello, then it will send a server hello. After the server hello, the server would send its certificate, the SSL certificate. In that SSL certificate, it has a public key mentioned, right? And once the certificate reach to the client, it will send a one more data, which is called the server hello data, right? So this is a hello between the client and server. After that, what we have called is a pre-master key exchange, right? So, but before pre-master key exchange, what we have, the server will randomly, with the some algorithm, generate the pre-master key with the help of an RSA. Okay, so the pre-master key is a seed of other keys. So it is the first seed of the other keys, right? So pre-master key is the first seed of the other keys. So this is generated by client. Pre-master secret is generated by the client with an RSA, right? With an RSA algorithm. Then this pre-master key from the client would be sent to the server, which is encrypted with the public key of server. So pre-master key generated. First thing, pre-master key is generated, but it could not be sent over the internet, right? As a plain master key, because anyone could decrypt it in the middle between the client and the server. So I don't want to send this pre-master key as a plain text. So what I will do, I will generate this pre-master key with some functions or the complex functions, and this pre-master key would be sent to the server with the help of the public key, server's public key, and encrypted. Okay, so it will goes to the server as a encrypted form. So server has its private key, it will decrypt it with its private key. Now the both the client and server has a pre-master key. Okay, now what the client and server will do, it will generate one more secret that called the master secret. So by using the pre-master secret and other functions, it will generate a master secret. Both of them will generate a same master secret. Okay, with that master secret, the session keys will be generated. So the sessions keys will be generated, and both the keys are same on the client as well as the master. So the first seed value is the pre-master. With once the pre-master is, and who will generate the pre-master? Pre-master will be generated by the client. Okay, so one we need to send this pre-master secret to whom? We need to send this pre-master to the server. So how we could send this to the pre-master to server? With the help of the encrypting it. And how we are going to encrypt it? We need a key, and which key we are going to use it? We will encrypt with the public key of the server. Once it reach to the public key to the server, the server will decrypt it with the its private key. Okay, now both the systems, client and server, have a same pre-master secret. The another value, with the help of pre-master secret, both of them will generate master secret. Okay, and with the master secret, they will generate us session secret, session keys. So, and both the server and client have the same session key. Okay, so it would be a same. And why we are using this session key? Because this key, both of them are the same key, and we will use as for the confidentiality and the integrating doing the data exchange. So these keys, and we are using only one key for the encryption as well as decryption. So that is what is a symmetric thing is happening, right? Not an asymmetric. One key is used for so session key. Suppose a session key is developed A123 A123. Okay, it has also session key develop A123. It has also a session key A123. So both of them will have a A123, and the same key will be used as a confidentiality and integrating doing the data exchange. So once the client is is done, exchange this pre-master key, both of them generate the master secret, the session keys. Then what is the next? Then the next is a change cipher sec. Okay. And so what is a change cipher sec we are doing over here? Change cipher spec is that signal that tells the other side I'm ready to use your secret code to the lock messages, right? So the change cycle is something like it's saying I'm ready to start the locking the message now. That is the uh, change cipher spec. Okay. So at this point we have after so telling each other that we are ready, right? At this point we both agreed on the session keys, right? The server and the client, we both agreed, they both agreed on the session keys. Okay. Then the client will send a quick message to a server that he's ready, let's lock all the message with our session keys. So whatever the message we are going to send, let locks our message with the session keys. This is the change cipher spec, right? And this server will also reply with this, okay, let's do it, let us start encrypting our communication with this one. There's one more thing, that's a finish encryption. After the chain cipher there's a finish encryption. And what exactly the finish encryption? It's a test message. So it will send a, it's a lock message, can you open it? It's a lock message, it's a encrypted message. It's a, the message is locked with the session key, right? So before the, so it's a kind of a test message which is locked with the session keys for the confidentiality and the integrity. But before that, what we have a change cipher specs, the change cipher specs that it will inform the server that okay, I'm ready, we have agreed on the session keys, now we are ready to change the cipher spec, right? So we are, let's log the message, whatever the we are sending from now onwards we are sending as in the log format. So the three things what we have a confidentiality, integrity, authentication. What we have a pre-master, master secret, session key. This session key is going to use for the confidentiality and integrity during the uh, real data exchange between the client and server. And the for each session there will be a session key. So when the session will be over, there will be another session keys will be generated, right? So pre-master key generated by the whom? Pre-master key generated by the client. How the client will send this pre-master to the server? It will could not send to the plain text. It will encrypt it with the public key of server, encrypt it and send it with the use with the help of pre-master key as a seed. Seed function, it will, what it will generate? It will generate the master key. Once it will generate the master key, what is the next? It will generate the session key. So both the server and the terminal will server and the client or terminal would have the same session keys. Okay, and both of them will agree on the session keys. Then the, once they are agreed on the session keys, then the client will send a message called the change cipher spec. From now onwards I will send all the message in the log state, that is with the help of the session key I will do the integrity and the confidentiality, that's the encryption and the integrity, right? Then it will send a finish encryption. Finish encryption is that it will send us some test message, okay, these are my test message which is a lock with the session key. And the same will happen with the server. So that is how the TLS 1.2 works, right? In TLS 1.3, that's a more secure, we will discuss in next session, but this is how the fundamental of TLS 1.2 done, or the TLS handshake is done. So if you explain this to someone during your interview or some discussion, then you are assume that you have a good stuff fundamental of the TLS. So what you need to focus on confident, whenever someone is asking discussing on the TLS, you should just focus on three words: CIA, confidentiality, integrity, authentication. Then pre-master secret, master secret, session key, confidentiality and integrity, client hello, server error certificate, server hello done. Then the client exchange could not be sent just with the plain text. It will use what it will leverage with the server's public key. With the help of server public key, this pre-master key is encrypted. Once it reach to here, he will open it with his private key. Then both the client and the server have the same pre-master secret. Then the pre-master secret will be used to create the master secret, then the session key and the confidentiality and entity. Okay, thank you so much.